In this video, we're going to work on some math problems related to volume of spheres. By the end of the video, you'll be able to find the volume of a sphere, as well as any missing dimensions. We're also going to discuss the relationship between the volumes of cylinders, cones, and spheres. If you're following along with printed notes, this is handout 4 in your volumes packet. Let's begin. The volume of a sphere can be found by using the formula V, or volume, equals 4 times pi times r cubed, which is r to the third power, divided by 3. Sometimes you'll see it written as volume equals 4/3 pi r cubed. I will typically use the first form of the formula. Sometimes the second formula is kind of helpful. Half of a sphere is called a hemisphere. So we will have some problems where they're asking us to find the volume of a hemisphere. This is easy. They just want you to find the volume of a sphere, and then you divide it by 2 in order to get half of the volume of the sphere. Before we start some examples, we're going to do some quick proofs. So let's go ahead and fill these figures out. We've got a sphere and a cylinder that have the same height. So this is the radius right here of the sphere, and this is the radius of my cylinder. And it's stating that if a cylinder and a sphere have the same radius and the same height, the height of a sphere would be 2 radius, and I'll show you that later. Then the sphere will have 2/3 the volume of a cylinder. We're going to prove that in a moment. But let's go back to the height of a sphere being 2r. So this is the height of the sphere. You may say that, yeah, that's the diameter. And so this is part of the height, it's half of it, which is, this itself is a radius, because a radius is just the distance between the center to the edge, and also this is the radius. So now we know that the height of a sphere is basically 2 times the radius. That's going to help us with our proof. So let's start our proof. The formula for the volume of a cylinder is pi r squared times h. Now, if we replace h, this height right here, with the height of the sphere, which is 2 times the radius, we're going to say pi times r squared times 2r instead of h. So in place of h, we're writing 2 times radius. Let's simplify that. 2 kind of stands on its own. Pi is going to stay as it is. R to the second times r is r to the third, because you have 2 r's right here, and you have a third r, so that's like r times r times r. So that's r to the third. Now, we're going to multiply the formula by 2/3, because we're saying that the volume of this is 2/3 of this. So let's multiply 2/3 times our formula for volume of a cylinder, and we end up getting 4/3 pi r cubed, which is the volume of a sphere. So how do we get from 2/3 times 2 pi r to the third to this? Well, 2 times 2 is 4. 3 on the bottom of a fraction gets multiplied with the bottom of this, and if 2 was a fraction, it'd be 2/1, so it'd be 3 times 1. So you end up with 4/3 pi r cubed. Let's go ahead and try some examples. In this example, we need to find the volume of a sphere with a radius of 3. So let's rewrite our formula. Volume equals 4 pi r to the third divided by 3. Let's plug in our values. We don't know what the volume is, so we're just going to write V. We know 4 is 4, pi is 3.14, radius is 3, so we're replacing r with 3, raising it to the third power, and dividing by 3. You may rewrite it as 4 times 3.14 times 3 times 3 times 3 divided by 3. If you multiply the top out, you're going to get 339.12 divided by 3. And then if you simplify it some more by dividing, you get 113.04. And that's our volume. Let's try another one. You may want to pause here, but just want to let you know before you start, this one is a little bit trickier than the last. So the formula is still, before we start the formula, we are given the diameter, which is 12. So if the diameter, which is the length from one end to the other, is 12, the radius is just half of that. So the radius is 6. So let's write our formula. Let's go ahead and plug in our values. V equals 4 times pi, which is 3.14, times radius, which is 6, not 12, divided by 3. If you multiply the top out, 4 times 3.14 times 6 times 6 times 6, you'll get 2,712.96 divided by 3. Once you divide it, you should get 904.32. Let's try number 3. I'm going to start by writing the formula. Go ahead and pause it and try it on your own if you'd like. I'm going to quickly plug in the values. Don't know V, but 4 is 4, pi is 3.14, radius is 5 to the third, divide by 3, multiply that out, you get this. Our next set of problems, we are going to want to keep our solutions in terms of pi. That means we don't want to multiply by 3.14, we just want to keep the pi there in the answer. When we do that, we treat pi almost like a variable, like the letter x. We just don't want to multiply it. We keep it in the answer at the end. We're going to our diameter is 13. So if the diameter is 13, half of 13 is 6.5. So that's our radius. Let's rewrite our formula. And let's plug in the values. Volume, which we don't know, is 4 times pi, which we're going to keep as pi, times radius to the third. Our radius, again, is 6.5 to the third. And we're going to divide that by 3. So the way we work with this is we multiply 4 with 6.5 times 6.5 times 6.5 again, because it's 6.5 to the third power. So 4 times 6.5 times 6.5 times 6.5 is 1098.5 pi. Now you're going to divide this by 3. You're just going to divide this number, 1098.5 by 3, and you're going to get roughly 366.17 pi, and that's our answer. Go ahead and try number 5. It's actually easier than 4. Pause the video if you'd like to try it yourself. I'm going to put up the answers momentarily. The formula is the same. When we plug in the values, we should plug in 12 for R. When we multiply the top out, 4 times 12 times 12 times 12, that's 6,912 pi. You're going to divide 6,912 by 3, and you should get roughly 2,304 pi. Number 6, I'm going to move through this quickly. They do give us the radius, so this one's going to be pretty easy. Replace R with 9.3. And then this should be your answer, 1072.47 pi. All right, we're going to start some word problems. A hemisphere has a radius of 7 inches. Find the volume of the hemisphere. So let's rewrite our formula. We don't know volume, but we do know 4 is 4. Pi is 3.14, and radius is 7 inches because it says so. So radius to the third. And finally, divide that by 3. Multiply the top out, 4 times 3.14 times 7 times 7 times 7 is 4,308.08. Divide that by 3, and you're going to get an answer of 1,436.03. Now, this is not the final answer because they are asking for the volume of a hemisphere, and we just found this volume of a sphere with a radius of 7. So if we want to find a hemisphere, because hemisphere is half of a sphere, we're going to take our answer and divide by 2. So 1436.03 divided by 2 is 718.02 inches cubed. Now it's inches cubed because we are finding volume here. All right, that is our final answer for 7. Number 8. A sphere has a volume of 288 pi inches cubed. Find the radius of the sphere. This one is tricky because they've given us the volume and we need to find the radius. So I'm going to do it 2 different ways. Let's try this one. We're going to start off by writing the formula. Volume equals 4 times pi times radius cubed divided by 3. And we're going to fill in the information. We do know the volume. They say it's 288 pi, so we're going to write that down. We know 4 is 4, pi is pi, and radius is unknown, so we have to keep it as radius cubed. We're going to divide the whole thing by 3. So this is where we may run into some problems. This looks really complicated. How do we work with this? There are lots of different ways, but I hate dealing with fractions. All of this, 4 times pi times r cubed, is being divided by 3. And if we remember our algebra operations, the inverse of dividing by 3 is multiplying by 3. And because this is one term, we're going to multiply this by 3, which means we have to multiply the other side by 3. Now, when we do this, the nice thing with this is that this 3 will cancel out that 3. 3 times 288 pi is 864 pi. Now, what's left over on this side is 4 pi and r cubed. Now, you're multiplying r cubed with 4 and pi. So what I'm going to do first is I'm going to do it step by step. I'm going to divide by 4, which allows me to cancel out the 4's. If I divide this side by 4, I'm going to divide that side by 4. Now, the reason I'm dividing is because 4 is being multiplied with pi and being multiplied with r. So that means if I want to get rid of the 4, I divide by 4, not subtract by 4. So on this left side, 864 pi divided by 4 turns out to be 216 pi. What's left on this side is pi and r cubed. Now, I want to get r cubed by itself, so I need to get rid of pi. How do I get rid of it? Well, pi is being multiplied with r, so we're going to divide by pi. If I divide this side by pi, I divide the other side by pi, and pi ends up canceling out over here. Pi ends up actually canceling out on the other side as well, so I'm left with only 216. What's left on this side is r cubed. In order to get rid of the cube, I needed to use a cube root. And I'm going to do it to both sides. Now, the cube root of r cubed is r. Cube root of 216 is 6. So our answer is 6 inches. So our radius is going to be 6 inches. It's not 6 inches squared because a radius is just a length. It's not volume. Number 9 is similar. I'm going to do it a little bit differently. So they give us a sphere with a volume of 972 pi. We want to find the radius of it. So here's the formula. But I'm going to do it a little bit differently, as I said before. This is the other formula we talked about. It's the same thing, except it's written differently. And using this other formula might actually be easier. If you want to do it the first way, you can try it on your own. It may be a good time to pause the video and try number 9 on your own, and then check at the end to see if you got the right answer. So, why is this easier? Well, we can get rid of some steps. We're filling in V, which is 972 pi, because they told us the volume is 972 pi. We're going to bring down the 4/3 because it says so. The pi we're going to bring down. The radius to the third we're going to bring down because we don't know what the radius is. Now, I have 3 terms being multiplied with each other. We know that we can actually get rid of a fraction by multiplying with a reciprocal. If you remember doing that from before, what I'm going to do is multiply this by 4 over 3, because 4 times 3 is 12, and 3 times 4 is 12, and that's 12 over 12, which equals 1, which means it kind of cancels it out. So this cancels out. If I multiply this side by 3/4, I'm going to multiply that side by 3/4 as well, which is, again, the reciprocal of 4/3. So 3/4 times 972 pi is 729 pi. How do I figure that out? Well, it's 3 times 972, and then you take that answer and you divide it by 4, and you'll get 729 pi. What's left over on this side after those two get canceled out is pi times radius cubed. Now, get radius by itself. I'm going to divide by pi, which means I divide the other side by pi. The pi's get canceled on this side, and they also get canceled on the other side. I'm left with 729 on this side and radius cubed on this side. Do a cube root. Cube root of r third is r Cube root of 729 is 9. So my radius for this sphere is 9 inches. We're going to try one more problem, and this is going to show us the relationships between cylinders, cones, and spheres. They want us to keep the answers in terms of pi. So volume of a cylinder can be found by using the formula V equals pi r squared h. If the sphere has a radius of 3 and a height of 6, we're going to replace r with 3 and h with 6. So when you multiply that out, pi times 3 times 3 times 6, we get 54 pi. Our cone formula is V equals pi r squared h divided by 3. Again, our radius is going to be 3. Our height is 6, and then finish out the rest of the formula. You divide by 3. So 3 times 3 times 6 divided by 2, divided by 3 is 18 pi units cubed. And for our sphere, we're going to write our sphere formula again. V equals 4 pi r cubed divided by 3. Replace radius with 3. And there's no place to put height. So 4 times 3 times 3 times 3 divided by 3 is going to get you 36 pi units cubed. So let's answer these questions. What is the ratio of the volume of a sphere to the volume of a cylinder? A ratio is a fraction. So they want the volume of the sphere on top, and they want the volume of the cylinder on bottom, because it says sphere to cylinder. So sphere goes on top, cylinder goes on bottom. Well, the volume of the sphere is 36 inches. Volume of the cylinder is 54 inches, or 54 pi units. So let's simplify this fraction. The pi's cancel each other out because there's one on top and one on bottom. And we're left with 36 over 54. But 18 actually goes into both of them. 36 divided by 18 is 2. 54 divided by 18 is 3. So the ratio of spheres to cylinders is 2/3. What this means is that the sphere is 2/3 the volume of the, this is a typo. It says 2/3 the volume of the cone. It should say 2/3 the volume of the cylinder. All right, how does the volume of the sphere compare with the cone? Well, sphere compared to cone. Sphere divided by cone, let's see, sphere is 36, so that goes on top. Cone is 18, so that goes on the bottom. So the pi's cancel out. I'm left with 36 over 18. 18 goes into both of them. It goes into 36 2 times. It goes into 18 once. So how do the two compare? The sphere is twice the volume of the cone. So the sphere is 2 times bigger than the cone. List the figures in order from greatest capacity to the least. Well, cylinder is clearly the biggest. It's 54 pi, followed by sphere, followed by cone. So something else you may want to write down is, this is pretty nifty. It's the relationship between cylinders, cones, and spheres. Now, a sphere is 2/3 the volume of a cylinder, and a cone is 1/3 the volume of a cylinder. Knowing these relationships will actually make certain math problems easier. Anyhow, that's the end of that. Now we've worked on volume problems with spheres, and you should be able to find volume as well as find radius. Good luck on trying some problems on your own.